Let's go. I really got the feeling today that everything is going my way. Now this is what I'm talking about. Every time I see your smile, it makes me shout. Let's go! Let's go! Nothing's gonna stop us today. Get on the bus or get out the way. We're cruising with the radio on. So turn it up to 10. Here comes our favorite song. Let's go! Let's go! Let's go! Let's go!
Hello, good morning, good afternoon, good evening, good dawn, good whatever, good wherever you find yourself. Welcome to another episode of IoT Tuesday. If you were with us last week, it was an awesome session with Olivier. Thank you so much for honoring the show. We talked about the need to simplify IoT, and to continue in that spirit, we're going to be continuing with our Wio Terminal series. When we come back, I'm going to be talking about how to use input output port on the Wio Terminal. If this is something of interest, stick and stay. We will be right back. Awesome, we are back. I think I need to change my, excuse me, I need to change my stream deck, because lately anytime I'm going to go to the montage, kind of like switch to the other scene. But anyway, which ways, it's all part of the fun. Uncut, we're learning a lot of things on the show. So last week, awesome session. Spoke to Olivier. He showed us the Azure Connect, sorry, Azure Percept. Why am I Connect? Anyway, so we're talking about Azure Percept. We also talked about the need to simplify IoT. Great content, great concept, a lot of things to look out for. We're going to continue from our Wio Terminal series. I think we talked about the LCD, or the UI perspective of things. Today we'll be talking about the IU side of the Wio Terminal. We're talking about input, output, the various ports, and then we'll see some code samples to do that. But as you know, before we get into it, you could probably see a lot of things happening on this side of things. So what I'm going to do right now is I have a couple of things I want to share with you quickly, and then we will jump into today's episode. So let's just get right into it. So the first thing you probably notice, let's see if I can get to them. So this might not be doing it justice very well. Maybe this might help. So I've got here the NXP Hoover Games Hoovercraft. All right, this came in sometime last year after I participated in the Hoover Games and stuff like that. I got this. Now the only thing we had set it up, to fly. The only thing that was left was the battery. So this came in not too long ago. So I am going to be fixing the battery onto it, and then programming the flight control module for it to be autonomous, and then we can take it from there. So if this seems like something that's of interest to you, don't forget to subscribe, hit the subscribe button, hit the notification bell, so that when I start to show this thing or deploy it, you will know. As part of bringing you good content and learning content, watch out for my new channel, which is Let's Experiment. That is where you're going to be seeing a lot of these kind of like drone builds, DIY. That's where you're going to see time lapses of me building and doing stuff. A lot of those will be on the Let's Experiment channel. If you don't want to miss it, please make sure you subscribe to the channel, hit the bell notification, and then when I release any video, you're going to get them. So the first thing out of the way is our drone. So let me actually set this somewhere here in the meantime and put this here. We'll get back to that. Now, the second thing I want to talk about, drum roll. You probably, if you're following me on social media, especially my Twitter feed, you would have noticed that I posted a picture sometime last week. Yes, this is something interesting, something I've been waiting for a while now because, as you know, currently I'm in Accra, Ghana, and it takes a while for things I have in the US or get from the US to get to me here in Accra. So eventually, the big one came in. This is a bit heavy, so permit me, oh my, to show you this. I'm going to keep it here. So as you can see, I have my Creality Ender 3V2. You need one. Definitely. You need one of the drone. Ephraim, see me in chambers. So my Ender 3V2, which is a 3D printer, came in last week. Oops, let me set this down. Oh, that's heavy. Yeah, so the 3D printer came in last week. And again, just like I mentioned, there's going to be an unboxing of the 3D printer on the Let's Experiment channel. There's also going to be the use cases. Yes, 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 yes. We got the 3D printer. Welcome, Peter. Welcome, Ephraim. Thank you guys for joining. Yes, yes, yeah, yes. A lot of interesting stuff happening on the channel. So one of the things you're probably going to see a lot of is now when we build our IoT circuits and stuff like that, we'll have we'll print nice enclosures and nice cases to do it. I'm actually trying to replicate a common thing that's actually been featured today on the Maker page, which is Benjamin Cape's I think he did something with a nose, which is AI powered, that's able to smell sensors. I'll try to do that. It also uses a Wio Terminal, so we will be playing around with that as one of the projects we do. Now, if you have any idea or suggestions on things we can 3D print on the Let's Experiment channel or things we can do with it, just send me a comment in the comment section, send me a tweet, contact me. I'll be glad to have that done. So that's the second thing. Yeah, yeah, yes, that's the mega, yes. Yeah, awesome. Yeah, so I promise. I mean, Let's Experiment is going to be an awesome channel where we kind of like put together everything we're doing on the IoT show, on the cloud show, and then on the power show. We put everything together on the Let's Experiment. We do things unedited, unscripted, uncut. Now, the next set of cool things I want to introduce you to. So if you've been following me, we've been talking about. Oh, and don't forget that it's also going to be featured in the Let's Experiment, the Lego Mindstorm, the new one. So if you want to see a lot of this content, don't forget to subscribe. Now, if you've been following me on my channel, I've been talking about my kind of like CSR or project I'm doing to help people bridge the gap of technology, the tech on wheels. So as part of that, we have, I don't know if you can see this, where you can see it properly. So I have here, let me put this here for the meantime. Let's move this. I'll bring this back so I can push this here. So I have here the Osmo coding block. Yes. So the Osmo coding block is it's a way to teach kids, I think from 3 and up, how to program using Osmo. If you're not familiar with Osmo, Osmo is a set of learning kits for kids that has a lot of different blocks or kits allow children to learn creative side, programming side, and all that. So we've got this that's going to make its debut on Let's Experiment how to use it. And it's also going to be part of the set of tools and kits that will be going for the Tech on Wheels project. So if you want to support us with, kits, with resources, Tech on Wheels will be really grateful. So we have the coding block here that we'll use. Then there's this one, the second part of it, which is the Osmo Genius starter kit as well. Also came in. So it's part of a kit that came in last week. So this would also make its feature. And here, again, this is not paid. All right. It's not like any paid sponsorship. These are things that people have donated or things I have bought with my own money for the project. And then here, we also have the this is the Little Genius starter kit. So this is kind of like more for kids 3 to 5, but this is for kids 6 to 10 up. So let's experiment, and Tech on Wheels is going to be an awesome journey. If you have your kids and you want them to learn these things, or you want to be part of Tech on Wheels, comment or reach out to me, and then I would make sure this happens. All right. So with all this out of the way, all right, let me throw the drone somewhere safe so it doesn't fall on our heads. Since we're not going to use them, let's keep them here for ourselves, and then let's get to today's show. Let me bring this down, and also don't forget that because this is we're in a new month. It also at AME, ask me anything. So if you have any questions you want, hey, I don't know if it's just me, but the Twitch stream doesn't seem to be working. Peter, thanks for that. Let's see what's happening on Twitch. If you're watching from Twitter or Facebook and experiencing the same thing, please let me know. It could be I get a black screen on mobile and error in my browser on PC. Peter, um, can you try Twitter? If you follow me at Twitter, is at Sadrany, Sadrany. If you go to my Twitter feed right now, you should see the same thing. Actually, let me check that right now. That is if that's not too much to ask. I feel Twitter might be. Let's close this. Let's check. Let's make sure that. Oh, okay. Oh, so you went there first. Let's see. This is. Uh. So let's see. Let's see. Yeah. So Twitter should be working now. Twitter is working now. So I don't know what's happening with Twitch, but oh, and yeah, I saw the more reason why I'm actually pushing to get a lot of subscribers also is that if you didn't know, YouTube has changed some of its live streaming thing requirement. So now, before you can actually do live stream without using Restream or stuff like that, you need to get 1,000, 1,000 followers. 1K is kind of like the minimum. Yeah, I think yeah. So I think the problem is only with Twitch. I don't know what's happening there. It could be, um, but if it's not too much to ask, you can join us either on YouTube or join us on Twitter, and the experience should be the same thing. Thank you so much, Peter, for that feedback. I really appreciate that. And if there's any other thing, just put it in a comment and I'll get that. Thank you so much. Uh, thanks so much for the feedback. So yeah, so let's help grow the channel. So today, what are we going to talk about? So we've been following, the Wheels Terminal right here. Let's go to the bench. So we've been using this. We've been using the terminal. Thank you so much. So we've been using the Wheels Terminal for a while now. Let me actually bring it this way so that I can have it turned the way I want to. Cool. So we've been using this for our Wheels series, and for some time now we've seen how to do the UI stuff and other specific things around it. Today we're going to talk about these ports. We're going to talk about the input output. So we're talking. You've realized that we have let me take this out first, and then we can show this. So you can see we have two groove ports here. One is I2C, one is digital, but both can be used as digital. And then if you look behind it, it shares almost the same 40 pin IO pin just like you have in the Raspberry Pi. So if I swing here, you realize that I have a Raspberry Pi here, and this also uses the 40 pin. It's the same thing here, all right? It's the same thing here, and so pretty much if you want to, add extra sensors, the same thing, you can reference this. And to do that, let me quickly share this. Let me show this right here. Oh, no worries, Peter. Thanks for, sharing, prompting us. I really appreciate that. So if you look at this closely, this actually shows as you can see it, the form factor for the Wio terminal, and then the various pin points. So from the top, you can see that there's 5 volts. So pins 2 and 4 are 5 volts. Pins 1 and 17 are 3.3 volts. And the rest are, pin 6 is ground, 9 is ground, 25, 39, 34, 30, and 20 are all ground pins. Then if you look at, we have, so 8, so pin 16 can actually be a PWM, can be a digital analog pin. Pin 18 can be digital or analog. Now, the cool thing with this is that you can reference, you can reference the pins with this name, the names as you see them, like BCM 14, BCM 15, 18. You can reference them by these names. It's actually allowed. So what we want to do today is understand the various concepts, of the input output on this pin. Let me give you a much bigger view. And hey, if you have any questions about this, you can probably ask, and I will, try to answer them. So you can extend it. All right. So to do that, let me actually bring this kit here for now. We'll get into the kit. So let's get in here now. So for input output of the Wio terminal, all right. So it actually, you can leverage the analog, all right. You can leverage the analog, the digital or I2C or the SPI interfaces, all right. So for for the analog pins, you can actually reference them by either A0 or A8. So you can see, let's see where that is. So reference them either by using the RPI A0 or RPI A8. That's referencing using the Raspberry Pi model of naming. But you can also use the same thing, use the names you've seen here in this schematic to reference them, and that also works. Now it's quite easy to set them up. Now depending on how you want to set, especially for the groove ports, the 2 groove ports we have, and if we switch to the so these 2 groove ports that we have, all right. Oops, is there a board for? Is this the board or version of it that was showing off the block list? No. So yeah. It's not this particular one. Olivier also has the same one. Yes, I know. Yes, we actually have one of those coming as well. And I'll do a review of it when it comes. But it's also almost of a similar one. I think that one is M5 something. Um, I would look for that and share with you. But yeah, it's not this one. It's of a similar type, but not this one. So yeah, so these 2 groove ports here can actually, let me tilt this here. Yeah, so these 2 groove ports can be accessed using the RPI A0, and then either A0 all the way to uh, the numbers you want to represent them with. So for if you want to use the group configuration, okay, for the AD port, um, you can use one as analog and the one as a digital pin. Let's go ahead and let's open um, our let's open this app. Let's open our IDE app. I actually had to do an install not too long ago, so hopefully I didn't break or mess anything up. All right, so we can talk about yeah, let's just update it. It's not going to kill us. So let's see. So let's update it. Let's update it. Let's up. Yeah, those that particular I mean was is really cool. It's just like bricks, almost like like the Mindstorm. So you look like it's like the Lego for IoT. That's how I want to refer to it. Okay, I think that's done. Installed a few. Okay, so let me go ahead and close and reopen this again. And let's open this. Fabulous last words here. So let's do this. So I'm going to for the last part of our series, this is what we had deployed on our Wio Terminal. Yeah, I think it's the M5. Actually, for the sake of people that don't know what it is, let's see. Um, let's do this. Let me quickly bring this up. And then um, let's share this with the people. Okay, yes, this is it. So it's actually called the M5 stack. Let's bring this here so that you people can see this. Yeah, let me bring this in view. Yep, so this is it. So it's the M5 stack, and as you can see, it's almost of the same form factor. Like with the Wio Terminal, you have a few buttons in there. Um, But the cool thing is, and this is the M5 quarter. So now the cool thing is you realize that this has the pins. All right, this has the pins along like all around it. Yeah, yes, this one. Yes, Peter, this is it, and it's ESP32 based. Now, so this one has all the pins around it. Uh, versus this one. This one has the 40 pins at the back and also two extensions for groove kit, like groove extensions. All right. Um, just to make for easy connections. But the cool thing about this one is that it's stackable. So you can actually, it's like like Lego pieces. You can stack it onto it. Yes, I think it has a few groove connectors as well. So you can stack it onto which, you can stack a number of them onto it. Actually, the Wio Terminal, all right, the Wio Terminal also has a similar concept. They now have a way for you to stack more wheels terminal on top, but they also have a base where if you connect it here, you actually get a lot more groove connectors for this. I'm not sure if it's on sale now, but they have one for the wheel terminal. Actually, let's see if we can find that and show. Um, X Yeah, extend. Yeah, let's see extend that. So what I'm doing is, let me see if I can find. Um, let's see. Uh, yes, this is it. So this is the one I was talking about here. So this is the extension for, as you can see, the Wio Terminal. So we realize that it has there you go. It has this. So which means I think this is be a better picture for that. Yeah. So if you have one of these, you can actually now put this on top of it, and then you have now extra groove connectors. And yeah, groove connectors are fun to work with because then you avoid all the soldering, all the breadboard, and all that. So that's one of the things. But yes, by the M5 stack, yes, obviously, I have one coming, so I'll do a full review of that when that comes. Another reason why I love this is also that the Wio is also now Azure compliant, so you can actually connect this to Azure to do stuff. I'll show this when we get to the network and the cloud episode for the Wio terminal. All right, yeah, awesome. So let's get this out of the way and then back here. So to make use, all right, to use to use the analog side of things, you definitely will need an analog sensor or something that shows up analog values. But for now, let's connect this. Let's connect the terminal. Let's turn it on. And yeah, let's come back here. So let's show this. So the very last thing we did was a question about how do we rewrite, write something onto the screen using two different colors. And we did this last week. So if this is something of interest to you, you can go watch the last week episode on how to do this. I explained the whole concept of how to do it, changing colors and changing the font. We did this, all right, last week. Now, we'll leave this on for now, and then we're going to move on to other stuff. Now, if you want to, first of all, I mentioned, so in terms of input output, you can have an analog, right, input. You can have digital or I2C, which is a way to do a multi-slave, multi-master, where you have a master speaking to a lot of the pins or microcontroller, chipset on the same device, on the same microcontroller. Or you can actually also use um, what we call the serial peripheral interfaces, okay, which is just a way that microcontrollers communicate between small peripherals like shift registers, sensors, and SD cards. All right, these are the three ways you can actually interface. So analog, digital, actually for analog, digital, I2C, or what SPI. So let's take a look at the analog. Obviously, um, if you want to use the analog, all right, you need to make sure that you are using an analog sensor. Let's see. I think, do we have a loud sensor? But let's do this. Let me do a new. Open this up. So in the setup for your terminal to use any analog devices, especially for Groove, all right, for the Groove connector, what you want to do is, let's go here. For the Groove, what you want to do is, um, obviously you need to set the pin mode, and like I mentioned, you can access the pin mode from the schematics from A0 all the way to A8. All right, so I can do something like and just let's see this so that it doesn't look like magic to you. I'm using that reference. All right, so as you can see, if you look here, so I can reference it by A0 or A1, all right, or A6, A8. This also can, this particular one, pin 13 can serve as a digital analog or a pulse width modulated as well. So between A all the way A0 to A8, that's what we're using. So it's not magic, okay? I'm not conjuring the numbers using the schematic of it, but ideally it's actually using pin 13 on the board, all right? But this is just a schematic of how to reference it. So let's go back to, so here in setting it up, if you've been doing a lot of Arduino or microcontroller things, you know that we need to set the pin mode, all right? And what we are setting is, we are setting A0, all right? And what is it? It's an input. So all we are telling our system is that, let's actually hold on first. All we are telling our system is that, hey, I am trying to set up pin 0 as an input, which means it will be taking an analog, it will be reading analog data, into the system. All right. And then another thing you can do, because sometimes you want to visualize this, right now, not on a Wio terminal now. I'll show that probably there's going to be a part 2 of this. I'll probably show this in a part 2. So what you also want to do is you want to enable your serial. All right, so let's do serial.begin. This is like some of the basic things. And here I'm going to use a higher baud rate. So let's do 115 200. Now this is actually going to be dependent on which device you're using. All right, actually, let's see if I can do this. You know what, let me bring this here. Let's see if we can find something in our kit that will give us some some uh, analog, 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 analog. I'm trying to see if I can find something, any analog. Okay, let's see this. So bear with me for a sec, people. I'm trying to get, this is an encoder. Um, mm, 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 mm. Okay, so what I was trying to do here is I'm trying to find, I think, let's do this. Rotary angle. I think rotary angle will be analog. So what I'm trying to do is to find, I was trying to get one of these groove connectors that we can use for this test. And then let me get a connector from the kit here. Okay, let's keep this somewhere here, closely packed. So I have this, and let me be sure of this. Let's quickly check this out from here. Let's check this. And yeah, if you have any questions, feel free to send, pop it in the chat. Rotary angle sensor. So I'm trying to do is I'm trying to get one of these so we can connect it to the terminal and then see how we can read it. It's quite simple as using any other board that has yep. So there you go. Okay, so and always look, this is it. If you're unsure about any of these kits, all right, seed or any, make sure you have the data sheet. The data sheet is going to tell you a lot about these things, all right. So let's check this out. This is pre-built. Let's see angles between 0. All right. Okay. And okay, so the baud rate is yeah, so we can use this. So you realize that we're going to use A0. So the baud rate for this is 9600. All right. So 9600. So what we're going to do is we're not going to use any define or anything. This is just going to print out the angles based on, how we do this. And then maybe in subsequent lessons, we'll see how we can take the output from this and write it on the screen. All right. Quite simple. So let's borrow some code from here using the analog. All right. So the same thing here, A0 input, right? So this has been defined as an input, but I changed the baud rate because that is what the analog, the rotary angle thing works at. So 9600 is the baud rate. We're not using any LED, so all we're doing is ensuring that our A0 is set to an input, all right, and then we have our baud rate started. Now, this is the cool part. Now, we want to either repeatedly show this, all right, so let's go ahead and change this a bit. This is setting the angle, so we're just going to copy this simple code here. Don't worry so much about the code. Actually, let's just, you know what, for the sake of simplicity, let's do this. So you understand, we're not going to do anything, crazy. So all we're doing is that we're setting in for the sensor value, which is reading. I think what we did for this one is we've not defined anything for it. All right, so we can do A0. Yeah, because this is what's happening. Okay, I can do this as a best practice. So I define this as a rotary angle sensor, okay, as A0. And then now I can say that instead of saying A0, but because we're using the reference, that's why I kept A0. But I can now say that it's an input, all right? And then here, when I'm reading the value, I can actually also say this, all right? So it's the same thing, all right? This is the same thing, but let's just keep it very simple, all right? Now, once we have this, let's go ahead and just print. This is all we are doing, all right? For now, okay, just to show this, and then we'll transition to putting in it. So basically, what we're doing is we are getting the sensor value, all right? That is depending on how you move this, all right? And then we're printing this. Oh, this is just too long, all right? Let's just do this. Let's do something as simple as this. Let's just say angle value, all right? And then we print this, and then we can delay for let's say 5 seconds, all right? So all we're doing, anytime this is moved, we get the value, we print it out, we delay for 5 seconds, and we do another one, all right? So basically, this is just, let me test this, let me make sure that this is okay. And whilst that's happening, okay, it's asking me to save. Let's save this in our IoT. I think we have what? Yeah, Wio. Okay, let's create a new folder here and call it, let's call this analog. All right, and I'll call this analog, and let's save this, and then we're testing this. Now, whilst that's happening, let's come back to the bench. Let's put this here. So as you can see, quite simple. I'm going to connect this, all right, and so I am sure I'm connecting it to the right port. Let's open this. So A0 is, let's see, okay, so this with this here, all right, so let's turn it this way. All right, so this is it. I have it connected here. All right, so I'm going to put it here. Let me twist it this way so you can actually see what's happening here. All right, so I'm going to pick this and let's connect it. There you go. All right, so this is connected. Yeah, that's the only thing about, all this. It's a bit okay. So yeah, there you go. We have it connected there. Let's leave it there. Now, before you test it, make sure, all right, that if you look down here, okay, if you look down here, just make sure that you are using the correct board. All right, you see that? So making sure that I'm connected to the correct board and the correct, device. So now seems like everything is okay. Let me push this onto our yep, there you go. Let's go to the bench, and we might not see anything loaded on the screen because we are not writing anything to the screen yet. But if we come back here and I go to Tools, Serial Monitor, now do you see what's happening? So if I as I'm twisting, all right, as I'm twisting, the value is changing. I wish I could actually take this on, but hold on, let's see. If I can, let's do this. Great. And other way to, okay, so okay, hold on. So let's see this. Let me, so yeah, there's a bit of, volatility going on there, but let's quickly switch. Let me try to do this. Forgive me, you see another blank screen, all right, but that's fine. But if you look at, here is it. So if you look in there, you see the angle is now 2, but as I move it, check that out. See the angle is moving to what? 187, 238, 286, 287, 88. So it's like around those. There is, I think there's some noise going on there that's affecting it. But so as you can see, I'm turning it down, and then that's back to 1. All right, that's back to 1. So all the way up. So here, as you can see, all the way here is 1023. All right, let's go here. And then when I turn it all the way to this side, all right, that is now back to what? 1. All right. So a simple way to, to write this would be to bring what we've done from the previous, episode, and then nip off is always some of, thank you so much, Peter. Thank you. Um, and then yeah, make sure you go check it out on demand when it's done. But have a great day. Stay safe out there. So now we're putting this on the terminal, all right, on the serial monitor. Now it's easy. We've seen how to write onto the screen. We can copy the same thing, and this time use it to set a value. All right. So I'm going to, let's do that quickly. So while this is still running at angle 1, let's do this. Let's go and borrow our code we used from here. And we won't use anything fancy. All right, we're just making it very, very simple. Very simple. So here, let's check this. As we're doing it, let's be very mindful. Let's check it. I'm I'm worrying this might break because when I did the reinstallation, I think I deleted some libraries, but I hope I didn't affect. Good. So that's done. Awesome. I'm not using any free font. If I want to use the free font, you know what? Let's go ahead. Let me quickly do this. And let's do this here. Go ahead. Let's do this. IoT. We use Blink. I think the basic. And the basic. Yep, there you go. We have free font. So I'm going to copy this. Come back to analog, and make sure it's in here. All right. So making sure that we have the free font in the same folder. So let's close this and let's bring in. So we are just here again. We're just putting together everything we've learned. All right. So I have the font. I have a TFT set up, and in here, let me set the rotation. As you know, we need to set the rotation, right? So to do that, let's start with a TFT. Begin. All right, we're telling it we want to start this, and then TFT dot set rotation. That's like a rotating it. We can still use 1 or 0, but just use 3. All right, and then we can fill the screen black. So TFT dot fill screen. And let's do this. So this is TFT black. All right. And then now, so this is just setting up the screen, all right? And then this second part is just setting up. So right now, ideally, we don't need this. I'll leave this here, for just a while. Then we can go ahead and set the font. All right, set the font and set all that. So I'm going to set this. Let's borrow some more code here. So we're setting the free font to this, and then the text color I'm setting it to red. All right, and then we're doing this. Now the next thing to do, here you go, is now in here. Once we get the sensor value, okay, instead of doing all this print, we're not doing that again. So I'm just going to put this here, all right, and say TFT draw. So this is what I am drawing, all right, the sensor value, okay, at position 1010, all right. So let's save this, and then we'll delay for like 5 seconds, and then we'll do another one. But I think I want to do 10 seconds, all right. So let's save this. Let's check our code, make sure everything is okay. So what we've done here is we're just going to be writing the sensor value as it changes. All right. So now, what's saying? Oh. What is it saying? Oh, yeah. So this is the problem we need to fix. All right. So we need to, because the draw string, all right, just draws a string character, and the value we are getting here, all right, is actually a car, all right. So we need to convert it from the int to a car array. Is that okay? So let's do this quickly. Let's do this, and we should be in business. So what I want to do, let me put this here so I'm not blocking your view. So in order to make this easier for us, what we can do is I need to define, a car byte and, determine all that. So we have our string, which we are drawing. So, but this is how do you call it? So we need to change this to a car. I'm trying to see what would be a better byte to do that. Let's do this. All right. Bum, 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 bum. So let's do this quickly. Let's change this. Let me change the byte size. Uh, 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 uh. Let's get this working. All right. So let's delete this. Why is this thing? Is this? No, it's not frozen. Ah, gods of demo day. Okay, let's do this. Let me do this here. Let's define that from this side. And this should solve our problem. I hate it when I hate it when the things start to misbehave. Okay, let's do this. Pa, 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 pa. Let me define this here. This would make it easy for us to fix this problem. Actually, if I define it here, that is going to be defining it all the time, and I don't want that to happen. So let's do it this way. Let's do it this way. All right, so let's do this. Let me do it this way instead. So I'm going to define a car. Let's say, let's make this maybe 20. All right. Actually, 16 should be fine. I don't think we'll go beyond that. So let's keep it an array of 16. And then let's do this. In here, since I already have this string of 16 here, I can go ahead. I'm just calling it a character string, so it can be you can call this any name. There's nothing wrong with that. So let's come here, and at the point where I'm going to draw the string, I need to change this to, or I can go ahead and say, no, let's actually do it in one line. All right, so you don't feel. All right, so let's do the whole of this. Let's go ahead. We can do this. So I am going to let me do this, all right, as a string for this, and I'll set that. Let me actually do it this way. I'm going to say a string of str should be equal to, make this a string, all right, of this sensor value. And then let me write the string, let's run this first. So let me check this. Hopefully I would not need to use that car, and that should make our lives very easy. And permit me, we might go like some 5. Yeah, there you go. So ideally I wouldn't need this any longer. Okay, so let's go over this. Everything from here is setting up our Wio terminal. We don't need this any longer. All right. Anything here is telling us that we're using pin A0 on the Wio terminal to reading analog, and all we are doing is that anytime as the application is looping, as we rotate the encoder, we're getting the angle, we are converting it to a string, and then we are drawing that on our Wio terminal. All right. So let's deploy this. And whilst that's happening, let me switch to the bench. So we see it happening. So let me position this. So it's deployed. It's running now. Take a look at this. Do you see that? So it's 1. I think I should bring this in. Good. So now, as you can see, it's 1. So as I move, do you see that? So as I rotate it, let me rotate it all the way to the end. The numbers are drawing. All right. So there you go. There you go. Oh yeah, this is happening. Let's deploy this again. All right. Ba-ba-bum. Yep, that is deployed. And there you go. So right now you see that it's 2. All right. And if I, oh, sorry, blocking your view. If I twist it, stay here. Let me push this here. if I twist it all the way to the end, 2023, right? So if I pull it back, so we're now using the analog, one of the groove ports connected to an analog sensor, and then we are drawing this on the screen. All right, so that's how to use the analog. So very simple to do. It's quite simple to build. Looks like we already ran out of time. Like 5 minutes. Okay, let's see if we can add. We talked about analog. Let's see if we can add a digital one. All right, we can add something digital. Draw that one as well, and then we can call that a day. So let's go back here. Let me put this on the bench so that you can see that. Let's do this. So which one would we use? Which let's do this. Okay, let's do this. Let's get this done. And yeah, if you have any questions, please feel free to share that. So how about let's quickly do this. Let's do this. Let's do this. Interesting. Okay. So the next thing would be here. So if we turn it, this one, the one closest to the 5-way switch, that's the A0, the analog one. If you want to use digital, you connect it to this one, all right? So for the digital connection, let's see what should we connect? Let's see what we can connect to our pin. A groove button. A groove button. We can do this with a groove button. Okay. So let's do this. Do we have a groove button here? Let's see. I think we do. And there's also the groove LED. Where is that? Where is that? Yep, I think I found it. Okay. So as you can see, we have a groove button here. If all right, if we want to connect the LED to it, we would have to disconnect this or use kind of like a pin, all right? But this is the groove button. Okay, let's do this. Again, connecting it is quite simple. That's why we love the groove connectors and the groove sensors. It's just, straightforward. And this is going to connect it to D0, digital, port 0. So let's do this. Put this here. And then this now, okay, this now has the pin connected. So the same way, we can go to our code base now, all right, and I can go ahead just like we defined. Let me actually do this, all right. Just like we defined the button, okay, I'm going to go ahead here and say that we're defining the button D0. And here, remember, we're referencing it with the names. If you go back to the schematic, you see this D0 here. That's it, D0. All right. So D0 and A0 are almost the same thing. So I can actually switch it. Let's do that. So let me move the encoder here. All right. I'm moving the encoder from here, and then we put in this here. So now, as you can see, Now the batting is on, because it's an analog input, okay? The batting is on D0. And let's bring, I have an LED here. I know I do. I just saw it. Where is that? I know I just picked it, so we do have it somewhere here. Oh man. Here. Yep. I think I have it's a changeable one, not the there we go. Or, you know, for the sakes of let's use a buzzer. Yeah, let's use a buzzer instead, so we can get yeah, there you go. Let's use a buzzer instead. Yeah, so we're going to use a buzzer, which is also digital. So again, let's connect this. I have the LED, but this is an RGB one, so we won't go with that. So let's connect this, and let's connect that to the buzzer. So if you do a digital to right on the buzzer, it should work. So let's bring this here. So we have this, and because we're going to use a buzzer, we don't necessarily need to have anything written on the screen if we want to, but let's just keep this two here. All right. Okay. Cool. So what we want to do is define. All right. It's an output. So here we can actually get rid of this, and this time around, so let's go ahead and define I'll say bars, all right, which is on, let's see that bars here is on, let's go back here and look at it quickly. Yep, so bars is on D1, all right. So we put bars on D1, so that's defined. And then in the definition of this, we need to say that, so button here is going to be an input, and then we set our bars to what? An output. All right. So pretty much this is what we have. Let's copy this somewhere. And yes, I think someone requested that. Yeah, welcome. Someone requested that, you know, I put this in a GitHub repo and share. So yeah, we're going to do just that. Okay. So here, what we want to do in here quickly, we are out of time, but we'll just finish this and test it out. So as you can see, we just have connected, you know, the Wio terminal. We have a buzzer and so an analog and then digital, right? So we're just trying to write the code for it quickly, and then we can share this. So let's go back to the code. So what we want to do is do this. We're not using any serial thing. So in here in the loop, in the void, or in the loop, what we're doing is, first of all, we are getting the button state. All right. We're reading. Hold on. Okay. We're not going to print anything. All right. And all we want to do is do this. Quite simple. So what's the button? Button, we're defining it as an input, right? So let's see it. It's digital 0. Yes. So there you go. So, and then the buzzer is, yeah, you can also use the buzzer as a digital. So now we're pulling it on the digital side. So we're saying we're calling the button state, okay? If the button state is high, so in this case, it's going to be the bars, all right? And then here, so if it's not, it's going to turn it off, and then we delay for some seconds. So let's test our code real quick. And if this runs, I think we're good to go. It's compiling. There you go. And make sure, like I mentioned, make sure you're using the seed studio. So let's go back here and let's push this. There you go. It will try to recompile and put it on it. So there's nothing at this point, but if I press this, hold on, let's see. I need to okay. Okay, as you can see, we need to hold on just a sec. I think I need to recompile again. Let's see. Pa-pa-pam. Let's see. It's not compiling. It's not compiling. That's strange. What? Okay, so I think what I did was to change. Let's see. Hold on. I think let's change this to A6. That's if I think it's going to be on A8. Hold on. So that's a good thing about defining the variable. I can just change it to one spot and I get everything done for me. Let me do this. And the schematics is here. Let's look at where A is. Yeah, that's it. So hold on. A6. Yeah, it should be A6. It should be A6. So yeah, I should put it on A6, not A8. So if we go back here, you realize that even if you press it, it won't function. So I need to change it to A6 because that's where the other one is. So let's change this to A6. Save this and deploy. So wait for that to, okay. Yep, that seemed to have written it. So, there we go. I hope you can't hear that. Hold on. What happened? Oh. So we have our button here defined in D0, right? We have it defined in D0, which is correct. Let's go back to the schematic and be sure we have it here. So that's D0 for it. All right. And then we've defined it. Just I'm now in debug mode. So we've done all these things. We've defined it as an input, right? So we have here, okay, let's bring this here. So D0, okay. Actually, let's see. And then let's change this. This also has DS, so it's a D6, not analog. It's a digital pin. And then this is also a digital signal. So let's push this. And yes, before we swing off, I'm very positive with this. I had to reference there. And hey, it's normal. I mean, look at, that's what I mentioned. Make sure you're looking at the reference, all right? You're looking at the reference diagram or the data sheet and make sure you're doing the correct thing, all right? So this seems to have been deployed. Okay. I hope you're hearing it. It's a bit, I don't know, it looks like it's a bit faint, but yeah. So yep, that is all time will permit us. You've seen how to connect an analog sensor to the Wio terminal. We've also seen how to connect the digital to it. Next week we'll try to do an I2C and maybe an SPI, and then that will conclude our session for the input output. And then the next episode after that we'll talk about networking and communication, where we'll connect a sensor. So that's why it's incremental. We're going to connect a DHT sensor to this and then collect the data and send it to the Azure cloud. So if this was interesting to you, please subscribe. And yes, today's code. Thank you for. So I deliberately, because I got carried away by what we're doing. So today's code. If this is the first time and you are hearing about the code, what I'm doing now is every month, I'm actually going to give away something. I'm going to give away a kit. I'm going to give away something related to IoT. Now, for you to win, you should have watched all my episodes within the month. And each episode, I'm going to show two codes. One usually at the beginning, somewhere in the middle, or at the end. Thank you so much, at the end of the show. However, if you watch all the episodes within the month, you are supposed to first subscribe to my channel, secondly, get the code, and then tweet or comment the code at me, and then every episode will have specific instructions. For today's episode, all you need to do, make sure you subscribe to the channel, put this code as a comment or a tweet at me, and then you stand a chance of winning one of the kits I'll give out at the end of the month. So today, there, this is the code for today. DRON. DRON. That's the code. All you need to do, make sure you're subscribed to the channel, and then tweet or comment this code at me, and then you'll be entered into the first week. All right. So if this was interesting, please subscribe, like, share, hit the bell notification so that when I send or put out any content, you'll be the first to see it. With that said, enjoy the rest of your day, your evening, your night. Stay safe, and let's get back together again next week for another episode of IoT Tuesday. With that said, I am out.